Okay, we are going to talk about beyond HD resolution cameras. I know the name of the session is 4K. It's a little complicated based on who's the panel. I'll talk about the panelists a little bit later. This slide just shows you there are all kinds of different ways of capturing this information. At the upper left, you're seeing a traditional super high vision camera. That's an 8K camera. It uses 4 4K sensors with 2 greens, and the greens are offset diagonally by half a pixel to get the extra information. At the top right is a new thing that NHK is doing with a single 33 megapixel image sensor with a Bayer filter on it. At the bottom left is what Sony is doing in their F65 with more than 20 megapixels in the sensor. At the bottom right is a more typical 4K Bayer filter sensor. Okay, why do we want this extra resolution? Well, you might have one heck of a home TV. In 2006 at the Consumer Electronics Show, Stan Glasgow, who's the president of Sony Electronics, said the next big leap in HD beyond 1080 lines could be in 3 to 5 years. Well, we're now 6 years later, but there are lots of companies that have shown 4K or Quad HD resolution at CES. This one is 150-inch Panasonic plasma. Why 150-inch? Well, if we look at what we have called normal vision for a long time, 20/20 vision, that's from a Dutch ophthalmologist named Snellen, who came up with the chart in 1862. By the way, for the Europeans among you, it's 6/6 vision. That matches 1080 line resolution at approximately a 70-inch diagonal at a 9-foot viewing distance, which happens to be what several researchers have found is typical viewing distance. Well, 70-inch for 1080 line works out to 140-inch for 2160 line. But that's if television is all we're concerned about. What about theaters? Well, here's a slide from ARI, which I'm using with their permission, and you can see that even at the back of this theater, you need at least 3K resolution for 20/20 vision. And towards the back of the theater, 4K, you get closer to the front, 8K. The people in the front row, I just have pity on them. But there's problems with the 30 cycle per degree theory, which is this Snellen 20/20 vision theory. One is there's edges. When you look at the E on the chart, it's a nice sharp edge. But if you talk about resolution in terms of cycles per degree, it varies from white to black and goes through all the shades of gray in between. Now notice that to get from a sine wave in the upper left there to something more approximating a square wave, I have to add frequencies that are higher, odd multiples of the original frequency. So that last bottom right thing in the top left image is the original plus 3 times, plus 5 times, plus 7 times, plus 9 times. Now I'm approaching edges. Another thing is look at the chart, and there's 3 lines below 20/20 on the chart. So even Snellen knew some people can see sharper. John Sprung, who's up here with his new lens, can see 2013. In April 2008, in the SMPTE journal, NHK published a paper. They've done some new research, and they found that it's possible to distinguish between 78 and 156 cycles per degree, and they only went up to 156, so they might find beyond that. They also found that something called realness is a function of the image detail. It rises rapidly to 50 cycles per degree, which is greater than the 30, and continues rising through 156 cycles per degree. So it's possible that even with ordinary television set sizes at ordinary television set viewing distances, we're going to get more out of higher resolution. Beyond HD spatial resolution, cameras from this list over here, the ones that are in white are actively selling higher resolution cameras. The ones that are in gray have shown something. And with very few exceptions, Astro, Hitachi, Ikegami, and Medusa, all of them have presented at various tech retreats, including this one. And there's displays from various manufacturers. CMO, by the way, is a company that makes displays for other manufacturers. And there's other gear, codecs, recorders, up and down converters, but not yet production switchers. Some of the beyond HD advantages, more detail, obviously, reframing or stabilization. If you have 4K, you can pull HD out of it easier. Single sensor 3D. This is a Z-Par lens on a Vision Research Phantom 65 with the 2 side by side. Increased sharpness. Here are some real-world MTF curves, modulation transfer function curves, or how much contrast you get out for some old Canon cameras with just a 14% linear resolution increase. And you can see the blue curve goes a little bit farther to the right than the red curve. What does that mean in the real world? Well, here's portions of some pictures. You may not be able to read the text in either of those, but I think you will all agree the left one looks sharper than the right one. And that's just a 14% difference. If we're talking HD to 4K, we're talking more than 200% increase. But there's also disadvantages. There's lens quality has to be greater. There's sensitivity and dynamic range tend to go down. You can compensate for that by using a larger sensor. You can compensate for that by using lower resolution. The data rate rises by the square of the linear resolution increase. So if you go up in resolution by a factor of 2, your data rate increases by a factor of 4. But that's the raw data rate. The compressed data rate should be much, much less. Some people have said as little as 5% overhead for going from HD to 4K. So our panel, we will go in alphabetical order of the companies. We'll start with ARRI, which has a camera that goes that slightly lower resolution route, but as a result is maybe improving dynamic range and sensitivity. Canon, which is using the higher resolution but outputting HD. JVC, which has come up with a consumer 4K camera for $5,000. Red, probably the first of the 4K cameras to achieve success in the field. Sony, with this imager that I mentioned before, 20 megapixels, more than any of the others in this group. Vision Research, which has the largest imager, it's a 65 millimeter imager instead of Super 35. And then Panasonic, whose AVC Ultra can now transport the 4K from the camera. So without any further ado, Stefan.